with this input, that is maximum speed 445, minimum speed 35, and how many speed steps are there? 12 speed steps. That means we have to calculate values from N1 to N12. Okay, how to calculate? For that, of course, formula to be used is range ratio right now. So range ratio Rn is equal to, you have to calculate that. All of you take out calculators. So range ratio Rn is equal to N max upon N mean. N max divided by N mean. Calculate.
12.71.
N max is 445 upon 35. Therefore, Rn is equal to
12.71.
12.71. This is range ratio Rn. Next, we have to find phi. Calculate phi by using equation Rn raised to 1 upon z minus 1. So phi is equal to Rn raised to 1 upon z minus 1. Rn is 12.71 raised to 1 upon z means number of speed steps 12 minus 1 11
1.26. 1.2600.
600.
Yes.
Phi is equal to 1.26. Okay. Range ratio, and what is this? Speed ratio. Range ratio, speed ratio.
Yes.
Okay. Now we have to write all the speeds. So first speed, what is the first speed in this case? The first speed is 35. That is N minimum. So N1 is equal to N mean. Next line. N1 is equal to N mean. That is equal to 35 RPM. Correct? How do we get next speed? N2 is equal to geometric progression. We know phi. Equation of phi is
N2 upon
N2 upon
N1.
N1. Also equal to N3 upon
N2.
N2. That means N2 is equal to phi times N1. Yes or no? N2 is phi times N1. So phi means 1.26 times N1 is 35. So this is the second speed.
44.1.
44.1 RPM. Third speed N3
5 times N2.
5 times N2. 5 into previous speed. Next speed is 5 into previous speed. Are you ready?
55.56.
5 into previous speed. So 5 is again 1.2. So you have to just go on multiplying this value again and again by 1.26. Okay? So 1.26 into 44.1.
55.56.
55.56
56 RPM.
Like this, we have to go on calculating all the speeds. You will find that final speed will be very close to 445. It will be 444 point something. Just verify your values. You will get those values like this. By using geometric progression, speed is reduced uniformly. Speed is reduced uniformly in different stages. Okay, you can see here 445, 353, 280, 220. So there is uniform reduction in speed, or if you say in terms of increase, there is uniform increase in speed. Actually, in reduction gearboxes, this is the first speed. First speed is motor runs at maximum speed, and from that, by using reduction gears, we get minimum speed at the output. Okay, so maximum to minimum. It's not minimum to maximum. Though while writing, we are writing minimum speed first, and then writing maximum speed. But in actual practice, how it happens? Motor runs at maximum speed, and by using reduction gear, you get this minimum or lower speeds. Okay. Now whether AP is better or GP is better. Okay. For that you can see this comparison table. In arithmetic progression, these are the what are the DK?
Diameter.
DK are diameter of the workpiece. At what speed, what diameter of the workpiece you should turn or you should machine. That is given here. So you can see first of all at DK, this is for AP. These values are for arithmetic progression and these values are for geometric progression. So what difference do you see here? In geometric progression, you can see after 181, in arithmetic progression after 181, the next value which can be machined is directly 88.
88.
But in geometric progression,
140.
181, you can get some value in between, that is 144. So which is better then? Geometric is better. Otherwise, say this is for which speed? 181 is for minimum speed, that is 35 rpm. And at 44 rpm, you can directly go to 88. What about in between values? आपको in between values को अगर मशीन करना है तो आपके पास स्पीड ही अवेलेबल नहीं है. Are you getting my point? From 181 to directly 88. इन दोनों वैल्यूज के बीच में अगर 110, 120, 130 इनमें से अगर कोई मशीन करना है तो there is no speed available. That's why it is said that arithmetic progression is poor in low spindle speed range and it is redundant. 14, 15, 17, 19 इतने स्पीड रेंज की जरूरत ही नहीं है, इतने स्टेप्स की जरूरत ही नहीं है. Okay, but in this case you can get at least like wider gap in the speeds. Okay, that's why geometric progression is better as compared to arithmetic progression. Okay, then in this case also you can see geometric progression gives optimum distribution of these spindle speeds. It gives optimum distribution because you can see as far as speeds are concerned, 35, here you get 44, here you will directly get 72. Okay, next you get 53, here you directly go to 109. So there is uniform distribution, that's why you get optimum distribution of speed in case of geometric progression. Okay, these differences you can prepare like what is the difference between arithmetic progression and geometric progression. What is one more advantage you can see here? AP, it gives complicated or expensive gearbox because there is large reductions in speed, so it gives complicated or expensive gearbox, while geometric progression gives compact gearbox. Gives matlab from by using these values we have to later on design the gearbox, its layout. That is our aim. Okay, so if you go by geometric progression, you get compact construction. By using arithmetic progression, you get bulky construction. That is the difference. Have you understood the differences? Which is poor in low range? Again, let us summarize. Arithmetic progression is poor in low spindle speed range and redundant in high spindle speed range. Okay. Geometry gives uniform distribution of speeds. Okay. Arithmetic complicated construction of gearbox. Geometric compact construction of gearbox. Okay. These things you can keep in mind.